Are you looking to improve the efficiency of your transistor modeling flow? Or make better measurements on which to base your compact transistor models? Or simply evaluate your semiconductor process? Then we have a perfect solution for you. Hi, my name is Jonas Urbonas. I am a senior product engineer with Maury Microwave, and today we will be speaking about synchronized pulsed AV and pulsed S-parameter measurements using our AMCAD software platform, our AM3200 series pulsed AV system, and Keysight's PNAX. Current and voltage, or IV measurements, are used to describe the relationship between a transistor's input and output currents and voltages. For a typical field effect transistor, this is usually shown as drain current versus drain voltage for a set of applied gate voltages. With modern technologies, such as gallium nitride, it's not enough to simply measure a transistor's performance under DC bias conditions, but rather, we need to measure the performance under pulse bias. The reason is simple. Due to high power density, these technologies can suffer significantly from self-heating, which can be seen as a droop in current on the measured DC IV curves. Pulsing the DC bias leads to quasi-isothermal and isodynamic device operating conditions and offers a better representation of the actual transistor's performance. Pulsed AV measurements also enable us to characterize transistors' performance in the breakdown region, something that would not be accessible with DC IV measurements. Controlling the quiescent bias during the pulsed AV measurement also allows us to isolate and characterize trapping effects such as gate lag and drain lag that can adversely affect the 3-5 compound semiconductor device performance. When synchronized with pulsed S-parameter measurements, pulsed AV measurements are an extremely useful tool in extracting compact transistor models such as AMCAD's GaN-HEMT, Angelov GaN, and ASM models. Let us see how this works. First, we will take a quick DC IV measurement and then see how constant bias results in current droop. Second, we will repeat the measurement with pulse bias and show the same curves without the droop. Third, we will explore synchronized pulsed S-parameter measurements under pulse bias conditions. Ready, set, go!
DC IV, PIV, and synchronized S-parameter measurements can be easily configured in AMCAD, the industry's premier device characterization and modeling software suite. The IV networks obtained in the DC IV and S-parameter measurement configuration reveal a substantial droop in the drain current due to the device self-heating. By contrast, the PIV measurements reveal no current droop. Moreover, the PIV measurements with time domain waveform acquisition enable analysis of the device IV networks at various locations within the pulse. Synchronized pulsed S-parameter measurements can also be performed for each IV measurement point and analyzed for stability, maximum available gain, and maximum operating gain.
With the AMCAD AM3200 series pulsed AV system, we can provide a pulse gate bias between -25 volts and 25 volts, currents up to 1.3 amps, and measure with a 16-bit resolution. We can provide a pulse drain bias between 0 and 250 volts, with currents up to 30 amps, and measure with an 18-bit resolution. All this with pulse widths as low as 200 nanoseconds and asynchronous long pulses up to 200 seconds. In summary, pulsed AV measurements are a useful tool for characterizing or performing parametric analysis on a transistor. Pulsing the bias allows us to operate the DUT under quasi-isothermal and isodynamic operating conditions and explore the device performance in its breakdown region. Adding synchronized pulsed S-parameter measurements empowers us to extract more accurate compact transistor models. With Maury Microwave's synchronized pulsed IV solution and Keysight's PNAX, you can overcome all the limitations of DC IV measurements, characterize your transistor's true performance, and extract the most accurate compact transistor models at frequencies up to 67 GHz. For more information, visit maurymw.com or contact your local field engineer. Thanks for watching.